Girls, I want to spend this lesson to go over inverse trig as a recap because I think we crammed everything a lot in one lesson. So I do want to break it down and go through a couple of steps that I didn't get to show last term. So, girls, when it comes to simple question like this, when it says to evaluate that, you can't just put that in the calculator and get the answer, all right? Here are the steps that you need to show in the exam to get the full 2 marks. The first thing that you need to do is when you see a question, you let theta equals to that, okay? Because we're looking for the angle when you evaluate that. Now, once you let theta equal to that, you need to write this. So the inverse of sine is just sine. So on the other side, you write sine theta is equal to root 3 over 2, okay? This is a step that you need to show from the first question. After you do that, then you can put it in the calculator, shift sign that, and you'll get 60 degrees. Now, if you have a look at ASTC, you know how sine is positive for this quadrant and that quadrant, but the reason why you don't get the angle in the second quadrant and you just leave it there is because if you look at the domain for sine, if you look over here, you only get the angles between minus 90 and 90, okay? So obviously if I got the second angle which is related to 60, that'll be 120, but that's outside of 90 degrees. So you don't write the second angle, you just have that one answer. And you need to make sure your answer is in radian mode, so that's pi over 3. Okay, so just keep that in mind. So this is the steps that you always got to show. All right, same thing for this question. So you let theta equal to that. That means cos theta is equal to -half. Now let's do this question like we normally would do in advanced. So if I press shift cos just the half, because that's the angle we want to work with, okay? So if I press shift just half, I'm going to get 60 degrees, which is the angle that you work with, remember, not part of the answer. So the angle, or the angles related to 60, and it's negative for cos, is in the second and the third quadrant. So for the second quadrant, the angle would be 180 take away 60, which is 120. And the third angle would be 180 plus 60, that's 240. However, the reason why you exclude the second angle, 240, is because if you look at the domain for cos, you only get the angle between 0 to 180, okay? And obviously 240 is out of that. Now, obviously now this answer in radian form is 2 pi over 3. So girls, what you'll notice, this is your final answer, what you'll notice in here, girls, to keep your working out short and to get you the answer straight away, if you do 180, take away shift cos, just the number without the negative, that gives you the answer straight away here, okay? So that's what this means, okay? And that's actually a useful fact that we're going to be using throughout these questions. Okay, so let's apply that. Let's have a look at question C. Now, when it comes to questions where you've got two trigonometric functions, you don't have to let theta equal to that. Just solve it, and here's how you do it. The first thing you got to do, as soon as you see cos inverse of a negative number, you want to write that, okay? So this becomes sine bracket pi minus cos inverse just a half. As you can see, it's not minus a half, just a half. All right, so this inside the bracket, basically if you put that in the calculator, you get sine bracket 180 take away that angle is 120. We've done it, okay? So, but remember you always want to write everything in terms of radian, so that's that. So inside the bracket is 2 pi over 3, and then you evaluate this in the calculator, okay? This is the part where you get to just put in the calculator and say that's your answer, okay? But you have to show this step. In the calculator, obviously, though, because it's in degree mode, you would type this in the calculator, not that. So sine 120, that's 0.86, which is root 3 over 2, okay? So this is how you have to lay out your working out. All right, let's do the same thing for this question. All right, not the same thing, different question. All right, now, we went through this question before. If you look at this question, you look at the what's inside the bracket first. Let's have a look at cos, and let's have a look at the angle. 5 pi over 3, if you're not sure, put in the calculator, 5 times 180 over 3. You'll find this is 300 degrees. So what you want to do is, first of all, does 300 degree, is that angle in the domain for cos? Let's have a look at cos's domain. It's between 0 to 180 only, so this angle is out of 180. So that means you need to find this angle that will fit in that domain. So here's how you do it. So using ASTC, 300 is like here, okay? So the angle is 60 degrees, which is pi over 3, okay? So now that we've changed 5 pi over 3 to pi over 3, if you have cos inverse of cos, so if you've got two of the same trigonometric function, the answer is just pi over 3, okay? So that's how you do that question. When it comes to questions where it involves negative angle inside a bracket, I really want you girls to be able to use one of these properties. In this case, we've got tan negative angle, so I want you to use this property. So when you have a negative angle for tan, it's the same thing as just putting the negative out because tan is an odd function. So I can write this inside as just negative tan and the angle without the negative, okay? So this question is just the same thing as tan inverse tan minus tan of that. Now the second question you've got to ask yourself is the same thing as before. Does this angle fall in the domain of tan? If you're not sure, that angle, 4 pi over 3, is 240 degrees. And if we look at the domain for tan, it's not in between minus 90 and 90, so we have to find the angle for that, okay? So 240 degrees, let's once again use ASTC. 240 degrees is in the third quadrant. So what the angle we want from here is that bit there. So 240, take away 180, will give us that angle there, which is 60 degrees. So what you want to do now is just replace that with 60 degrees. So the question now is tan inverse of minus tan bracket 60 degrees or pi over 3. Okay, so this is how you set it up. Now, if you got negative inside the bracket of tan inverse, have a look at the property over here. If you have negative inside the bracket, the negative just comes out. Okay, so the answer is basically put the negative out. And because you got tan inverse of tan, they're the same thing. It's just minus pi over 3. Okay? So that's your answer. That's how you solve it. If you get a negative angle, I really want you to utilize these properties. Okay? Now, with this question though, cos inverse, let's do the same thing. Apply the negative properties. So cos inverse of negative angle. Now, we can't use that for this one just because this is not one of the exact values, okay? It's not like half root 3 over 2 or root 2 over 2. If you don't have an exact value inside the bracket, you need to draw a right triangle using ASTC. So here's what I mean. So we've got this triangle here. Now, let's have a look at the domain for cos inverse, okay? We want to know where to draw the right triangle, here, 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 or here. If we have a look at the domain for cos inverse, it's between minus 1 and 1, and the range is from 0 to pi. What that tells me is the triangle here has to be in between 0 to pi. So it's going to be one of these two angles, 0 to 180 degrees. The question is here or here? The answer is here, because everything is positive here, and cos is negative for sine, and we've got a negative number. So draw a right triangle in this quadrant. Okay? So this is the opposite, adjacent hypotenuse. And let's apply that here. So we've got adjacent here. Is my mic on? Yep. And hypotenuse there. So my adjacent is here. And the hypotenuse is here. Notice I didn't write minus 2. It's just the length that I'm concerned about because I want to find that. Using Pythagoras, that's just 3 squared take away 2 squared. 9 take away 4, which is 5. Okay? This is what we're now going to use to find the answer for tan. Tan is opposite of adjacent. So this is my opposite, this is my adjacent. So my answer is root 5 over 2 with the minus included because tan is negative in the sine quadrant. Okay, so that's how you do that problem. All right, so now let's apply all of this into one of our HSC questions in your booklet, question 34. They want you to find the exact value of this. All right, so what you want to do is let's evaluate these questions one at a time. So to find this, remember the formal working out is you let theta equal to that. So sine theta is equal to root 3 over 2. So now if you press shift sine that, we did this in the beginning. So this is pi over 3. Okay, so that's fine. Now with this one though, negative, we've got a negative angle. So let's use this property here. If you have a negative angle, it's just the same thing as putting negative outside. Notice we have another minus outside. So that means, actually, you know what? Let's just look at it like this. Let's just ignore that minus in front. Let's just focus on this. So this is the same thing as writing using the property sine inverse with the minus outside, but the minus is now gone inside the bracket. And we know strictly what that is. I've just found it here, pi over 3. So what I have now is minus minus pi over 3. Minus minus pi over 3, which is plus pi over 3. We'll evaluate that later because now I want to do this. Once again, I have a negative inside the bracket. So let's now use this property. Negative x becomes pi minus that. So ignoring the minus here, let's just focus on this. So I can write this. This is the same thing as writing pi minus cos inverse half without the negative. And cos inverse half in the calculator is 60 degrees. So this is the same thing as writing pi minus pi over 3. Okay? Now let's put the minus back. So we're going to put a minus here, but this becomes positive because minus minus is positive. So now the answer is all of that put together. So we've got pi over 3 plus pi over 3. That's 2 pi over 3 minus pi plus pi over 3. Okay? So basically, if you put in your calculator 2 over 3 minus 1 plus 1 over 3, you're going to get 0, and that's your answer. Okay? So this is how you lay out your working out for this question. Okay? All right. To work with this, it's just a matter of using domain and range for sine inverse. If you look at sine inverse domain, it's this. So all you need to do is now just replace the x with the bracket inside. 2x minus 1. Okay? Now solve that. Minus 1 plus 1 to both sides. So that becomes 0 here. 2x, 2 here. Now divide both sides by 2. That's 0 here and 1 there. Okay? Now for the range, so this is for the domain. For the range, using that, if you have a 3, that just means you're multiplying 3 to both sides here. Okay, that's all it is. So your range is now minus 3 pi over 2 and 3. I'll just write 3y. Okay, actually, no. Yeah, that's like your final answer. And what you want to do now is draw sine inverse graph with this domain. Because remember, sine inverse looks like this. Minus pi over 2 is pi over 2. Now, this whole thing changes with this. So instead of going from minus 1 to 1, it's going to go from 0 to 1. So in blue. Okay, as you can see, it's from 0 to 1 now. Now we've got to further shift this so that it's from minus 3 pi over 2 to 3 pi over 2. In order to do that, just change the value here. So minus 3 pi over 2 and 3 pi over 2. And get rid of your old graph. And that's how your graph would look like for your answer. Okay? So it's just that. Okay? And this technique applies to cos inverse and tan inverse as well. Okay? That should wrap up inverse trigonometry, and you should be able to do now the HSC booklet questions. There are quite a few tricky questions from the booklet, but have a look at the full solutions to guide you. Okay? There are a lot of techniques to take away from the solutions. All right? Thanks, girls.